Let's continue. So we move from modules now to encapsulation and backsheets. We've heard already quite a bit on backsheets, and we're happy to have with us now not Stephen Tang, I believe, because he couldn't make it. Actually, instead of Stephen, it will be Kevin Wu from First. Who will present the material side of module reliability packaging solutions for TOPCon and HTC solar modules. Kevin, the floor is yours.
Okay, good morning, schönen Morgen. I would like to share my presentation. Can you see my screen?
Yep, I think you have to go into presentation mode.
All right. Yeah, I could play.
Everything fine.
All right. So, 但翻译一下. Okay. Yeah, I will start. Good morning, everyone. Here is Hangzhou First. I'd like to introduce about the packaging solutions for TOPCon and the heterojunction. In the past, I think we all experienced different type of models, and especially the cell technology development in the past, like BSF and the PERC cell technology, and now it is TOPCon and heterojunction, etc. Based on the cell technology development, we always develop the suitable encapsulant for the best solution. So now I think the key topic in the market is TOPCon and the heterojunction. So we can also see the challenges when you compare the challenges from the past and the current. You can see that in the past, I think the yellowness and the adhesion, PID, signature, etc., all these things were the main challenges. But now we are facing extra challenges. For example, for the TOPCon, the MID, it is a big challenge, especially for the glass backsheet TOPCon model. And for the heterojunction, it is more complicated, like the UV downgrade and also the moisture and the adhesion, etc. So for all these challenges, we try to offer the reliability. We can start with the TOPCon reliability introduction. So for the TOPCon, when it is glass to glass, I think it's rather stable, and the moisture mainly comes through the lateral side. And you could see that there are different kind of combinations for the TOPCon glass model. So you can see that in the market, POE plus POE and the EP plus EP, and also even EVA plus EVA for the TOPCon. And you could see that the moisture barrier is different for different kind of choices. And when you see the PCT test, you could see the test conditions there, 121 degrees and 100% relative humidity, and it is TOPCon Leco cell. And you could see that the POE has the best performance, and then it comes the EPE, and the EVA is the third. So you could see that it is, how to say that, with POE, it has the best reliability. And if you see the anti-PID property, by using our POE, it is offering the long time anti-PID property, as well as you don't have to worry about the light recovery when you use the POE on both sides. And for our recommendations, we always have two. One is the reliable solution, which is POE plus POE on both sides. And if you consider the economical solution, it is either EPE on both sides, or even you could see that some are trying EVA on both sides. And when we switch to glass backsheet TOPCon model, it is more challenging because the pathway of the moisture, it is not just from the lateral side, it is also coming through the backside, through the backsheet. So it has more challenges than glass TOPCon model. You could see that it is the PCT test comparison. So the test condition is 121 degrees Celsius and the 100% relative humidity. And we use TOPCon cell. It is TOPCon cell type A. And we used our transparent backsheet. And also on the rear side, we used our EVA film. And when you compare different three front films, our N-type POE has the best performance. And when we test on another type of TOPCon cell, the result is similar. And also a third type of TOPCon cell, you could see the similar result as well. So when you see the DH test, it is the comparison by using our N-type POE on the front and the market EPE, and the backside, it's similar. We still use our EVA and our CPC backsheet, and the condition was 85 degrees Celsius and the 85 relative humidity. And our choice can pass 2000 DH 2000 hours. And this test was done on TOPCon cell A. And for TOPCon cell B, we could see the similar result. So this is the reason why our TOPCon, the N-type POE performs well for the glass backsheet TOPCon. I think the POE itself, it has the low moisture vapor transmittance rate, and our TOPCon POE, it also has the anti-electrochemical property. So these two properties offer the specialty for our N-type POE film. So for the glass backsheet TOPCon model, we also have two types of recommendation. One is reliable solution, which is using N-type POE on both sides. And for the backsheet, you could choose different type of backsheet. And for the economical solution, we recommend to use N-type POE on the front side, and on the back side, you may use anti-acid EVA or white EVA. So then we switch to the heterojunction encapsulation. I think heterojunction, as we explained, it is more complicated. For example, the UV light, which is very difficult topic for that. For the UV part, it is usable to generate the power, but it also do harms to the heterojunction cell itself. So our solution is we have the down conversion film for the heterojunction, and you could see that the wavelength, which is in this range, the UV light range, it's switched to the visible light, the blue light range, and the blue light can be used for the power generation. And this is the comparison of the three type of model. If we say the UV cutoff film used in the front, it is the standard model. And we have UV through film used as a comparison, and the UV conversion film as a comparison tool. So you can see that the UV conversion film model, it has the extra power gain. It has 1.35% extra power gain. And this is our showcase, which is used in our outdoor power generation. So you can see that the down conversion film, it offers extra power gain in reality, in our real experience. So in the end, we would like to introduce ourselves a little bit. We are Hangzhou First, and we produce encapsulant, and both encapsulant and backsheet. Our encapsulant capacity is bigger than 380 gigawatt in total. And for our backsheet, we have higher than 50 gigawatt capacity. So we are one of the leading backsheet makers as well in the world. And we have 6 different factories which are located in Thailand, Vietnam, and China. And for the backsheet, we also have long history of the production. We started from 2009. At that time, we started with CPK type or CPC type, KPK, etc. And then with time going on, based on the customer's demand change, we developed different type. Currently, we also have the water barrier backsheet for TOPCon and the heterojunction use. That's it. Thank you very much for your attention.
Thanks, Kevin. It was great. We will have you later on the panel. Let's then have it like we had it with the previous speakers, that you please answer any questions in the chat. I think there was one, and there might be probably more. And then we talk later again on the panel. Yeah.
Okay. Yeah, thank you. Yeah,
Okay.
see you later.
Thank you.
Yeah.